Hi, I'm Clay McGinnis. I'm one of the engineers at Wherobots who built our new MCP server. I think it's the best way to explore a spatial catalog, introspect your own data, and generate some simpler insights on smaller datasets. It can also help you create Jupyter Notebooks or Python files, which can be run in Wherobots Cloud to process very large datasets. I'm going to walk through how it can be used today. First, I'm going to start with catalog exploration. So I'm going to ask our MCP server what taxi data I have in Wherobots. It's going to make a number of requests using its MCP tools to our catalog endpoints and find out anything it can about taxis in our system. So this first request looks for any catalogs that we have. The second one checks for databases and tables using the hierarchy. And then here it's doing several described tables, which are going to get the schemas and the descriptions. And as you can see here, it's found at least one, looks like 3 taxi datasets inside of our account. The first one is from Wherobots Pro data, which is available to any professional edition customer in Wherobots. The last 2 are specific to our account, so they're custom catalogs and tables. This would show you as well that our MCP would pull anything from your catalog as well as our exposed catalogs. Awesome. Let's look a little bit at data exploration next. So let's ask how many pickups we have in that. So this will be the first query that we're going to have to make against the actual database itself. So it's going to do a select statement against this pro data catalog. So you see it's already connected to the database. It's doing its execution now, and then it'll return the result here shortly. You can use this feature for queries like this, which are going to be, more exploratory. You can use it for metadata queries. You can also do this for any kind of query of a certain size. As I sort of mentioned earlier, I recommend keeping the queries in MCP relatively small because the duration can get a little bit large. So when you think it's going to be large, I recommend moving over to a Jupyter Notebook or a Python file. Okay, the query is complete. So 185 million taxi pickups in the ProData NYC Taxi dataset. Very cool. All right, let's go ahead and look at how we can answer some specific queries entirely using the MCP server. So an example here that I'm going to do is find all the burger joints near the Space Needle in Seattle. So I didn't specify the dataset. I didn't specify the location with extents. I didn't use a polygon for Seattle. I didn't use latitude, longitude for the Space Needle. So it's going to have to infer and find out everything it needs for this. As you can see, one of the benefits of this being an agentic workflow is that it has made a couple of queries here that were unsuccessful, and now it's going back to the schema itself to make sure that it understands what it needs to be searching for. So after several iterations, we'll expect that one of these queries is going to correctly execute, and it looks like here we've got one that's lasting a little bit longer. So we'll see if this works using the technique that it wanted. So yeah, as you can see, we send back pretty informative errors for the LLMs to work with, and we've got our result. So we've got 4 locations within walking distance of the Space Needle. And yeah, this would be a great example of what we call Q&A. So, all right. Lastly, I'm going to give it a much larger query for this, but I'm going to have it create a Jupyter Notebook for me. So what I've got here is create a Jupyter Notebook using examples from Wherobots docs, which finds all the burger joints that are within 1 mile from a fire station. Check that all queries will work at a small scale before using the notebook. These are a couple of helpful tips use the docs is number one, and two is check all the queries will work. By doing both of those things, it's going to make it much more likely that this notebook will run start to finish without needing multiple iterations. Otherwise, if you were a data scientist or a data practitioner, you'd be able to more easily edit this notebook and make it work the way that you want it to. So these queries that I've got I've got it running, I specifically asked for small scale because, as I said, I want this notebook to do a very large query. I want it to find all of throughout the entirety of the US. But that's going to take a little bit longer to run. So now it's going to quickly try a couple of different queries. It should hopefully be able to fix ones that it does wrong. So here we've got VS Code doing a summarizing conversation history. This can take a moment, so I'll pause. Okay. VS Code always summarizes conversation history when the context gets too large. So it's found the correct category for fire department, and it already knew the correct category for burger places from above. One note here, you can see auto-approved for this workspace is appearing underneath each of the query completed. It'll prompt you the first time that it tries to do a query if you want to auto-approve or if you want to do allow for each single one. That's up to your own safety thresholds. Generally speaking, our MCP server cannot do write queries, so it will reject any sort of query going to execute query, the tool, if it's going to modify, update, change anything. So I generally feel safe enough to auto-approve. It does cost money. It's a tiny runtime, so it'll be a reasonably small amount, but that's the main reason for having an approval step. Okay, so it's creating a file. Let's see what it comes up with. A note on model choice here. So I'm using Claude Sonnet 4.5. I consider that to be sort of the best all-around model to use, bearing in mind price, performance, speed. And generally speaking, MCP servers work best with models that are pretty powerful. There are plenty of models that work with our MCP server. We've tested smaller models, Haiku being kind of our lower end from Claude, but there are plenty of new and open models that can also work great. So, all right, so it's created a file, and it does Sedona context, which is required, loads fire station data, burger data, does a spatial join, calculates some summary statistics, closest matches. Perfect. Why don't I go ahead and download this, and I'll upload it into Wherobots Cloud real quick, and we can give it a shot. Okay, so here we are in Wherobots Cloud. I'm going to go ahead and select a kernel for this and run all cells. This can take a little while just because it's going to work on larger data. So I'll go ahead and let it kick off and spend some time. All right. So one thing that I noticed is that this only did it on Seattle. This is likely due to the fact that I told it to validate all its queries and closeness. That's okay. It's probably better for a demo anyways, but you could change the extents of this at this point. Obviously, it returned a lot of information here, but it shows here a couple of very, very close ones here. So we've got one a teriyaki and burger, which is within 0.03 miles of the 11th Seattle fire station. And then we've got, yeah, sort of another look at it here, which is in meters. So great. Yeah, generally you would do this if you had a larger data set that you wanted to look at, you wanted to take a lot longer, you wanted to turn this into a job run. These would be great reasons to have it generate files for you. So yeah, that's all I have to share. It's very easy to get started. We've got docs that we can share with you. You can contact us specifically. Otherwise, we have posts for this, and we would love for you to try it out and share your feedback. Thanks for watching.